So you've always wanted to learn about Istio and you want to get into service mesh technology. Learning a service mesh technology for the first time can be super daunting. There's a lot of terminology and things to know about and learn. In this video, we're going to be taking a look at Istio, and we're going to be breaking it down into simple terms. We're going to deploy my video catalog microservice architecture, add a mesh to it, and see what we can do with the service mesh. Now, we have a lot of features to cover, so without further ado, let's go. So the first question to ask is, why a service mesh? A service mesh helps us solve specific challenges around service-to-service communication. If you're totally new to service mesh, you have to pause right here and check out my link down below to my introduction guide to service mesh, where I cover all the challenges and reasons you could be looking at a service mesh as a solution. So we're going to be taking a look at getting Istio installed, the useful things we can do, observability and metrics, how to detect network failures and faults, automatic retry of requests between microservices, traffic splits, Canary deployments, and TLS between microservices. But the first thing we're going to need is a Kubernetes cluster for our microservice architecture. In our architecture, we have a video HTML website. It's exposed via an ingress controller on servicemesh.demo/home. When it loads up, it makes a call to the playlist API. Also exposed by an ingress controller over servicemesh.demo/API/playlists. The playlist API retrieves the playlists from a Redis database. For each video in the playlist, it calls the videos API, which is a private service in the cluster. It has its own Redis database. After the playlist API has retrieved all the videos from the videos API, it sends the JSON data back to the videos web, which renders it in the browser. So if you take a look at my GitHub repo, in there I have a Kubernetes folder, and under the Kubernetes folder I have a service mesh folder. Under the service mesh folder I have an Istio folder with a README, and in here we have all the steps that I'm going to be showing you guys today. So be sure to check out the link down below to the source code so you can follow along. So if you head over to the Istio site and you go over to Docs and you go into Setup, Istio has a platform setup guide which helps us prepare many types of environments for Istio. And these are different Kubernetes clusters on different cloud providers, including Kind. In this demo, we're going to be running a local Kind Kubernetes cluster. Kind is a great tool for running Kubernetes clusters locally inside of Docker containers. So to create a Kubernetes cluster, we're going to say Kind create cluster. We're going to call it Istio, and we're going to run Kubernetes 1.19.1. So I'm going to copy this, I'm going to paste it to the terminal, and that'll give us a Kubernetes cluster within a Docker container that we can use and throw away when we're done. And now that our Kubernetes cluster has been created, I can say kubectl get nodes, and we can see we have a 1-node Kubernetes cluster up and running, ready to go. So now that we have a Kubernetes cluster, the next thing we're going to do is deploy our microservice video catalog. So we're going to go ahead and deploy an ingress controller, and then we're going to proceed to deploy the playlist API, playlist database, videos API, videos web, and videos database. So to deploy the ingress controller, I'm going to create a new namespace called ingress nginx, and then I'm going to apply the ingress nginx YAML files to my cluster. And then to deploy my applications, I'm going to say kubectl apply, and I'm going to apply all of these microservice YAML files. So I go ahead and paste that to the terminal, and that'll deploy the entire architecture to our cluster. And if we wait a couple of seconds, we can make sure that our applications are running by saying kubectl get pods, and we should see all of our applications up and running. We also want to make sure the ingress controller is deployed correctly. So to check that, I say kubectl in the ingress namespace get pods, and we can see we have 2 nginx ingress controllers up and running. So to test out our microservice architecture, we're going to need a fake DNS name. So to do that, I'm going to create a fake DNS called servicemesh.demo. To create that, it's very simple. I'm just going to go ahead and edit my host file and add the following entry. And then to access the DNS, we need to port forward to the ingress controller pod. To do that, I'm going to say kubectl in the ingress namespace. I'm going to say port forward to that ingress controller deployment on port 80. So I copy that, paste it to the terminal, and if I go to the browser on servicemesh.demo/home/, I can see we have our application videos web running in the browser. And you can see it's pulling out all the list of playlists as well as videos inside each playlist. The explanation for all the architecture is under Kubernetes Service Mesh in an introduction README. In this README, I explain the full architecture in detail, as well as an architecture diagram and how to build and run these applications locally in Docker containers. So now that we have a Kubernetes cluster and we have some real-life microservices with network traffic, let's take a look and see what it takes to get Istio installed. So to install Istio and download all the dependencies, what I'm going to do is I'm going to open up a new terminal and I'm going to run a small container to do all the work in. So what I'm going to do is I'm going to say docker run -it. I'm going to mount in my home directory into root because that's where my kube config for my kind cluster lives. I'm also going to mount in the working directory, which is this entire GitHub repo. I'm going to mount it into a folder called /work. I'm going to set that as the working directory, give it host level networking, and run a small Alpine container. So I run and I paste that into the terminal. So now I have a small dev environment in a container to install all the dependencies. So firstly, what I'm going to do is I'm going to install curl and nano, and I'm going to use curl to download kubectl. And nano is my lightweight text editor. So firstly, I'm going to say curl and I'm going to download the latest version of kubectl. I'm going to give it execution rights. I'm going to move it to user local bin. And then what I can do is I can say kubectl --help, and we can see kubectl is now installed. I can also set my default kube editor to nano, so that allows me to edit Kubernetes objects. And to test whether this container can access my Kubernetes cluster, I can say kubectl get nodes, and we can see our Istio 1 node Kubernetes cluster is accessible and up and running. So the Istio documentation is a great place to start. They have a getting started page where they show you how to download the Istio command line utility and install Istio to your cluster. So Istio also has a download Istio URL that you can run using curl, and you can pass in the Istio version that you want. And if we take this command and we run it in the terminal, that'll go ahead and download Istio, including the command line utility. And what this command does is it goes and downloads Istio and extracts a tar file into your local directory. We can see if we take a look at the root of my GitHub repo, there's an Istio folder that's been created. And in here is a binary folder with the Istio CTL command line utility. There's a ton of manifests, sample codes, add-ons, demos, tools, and a bunch of other cool stuff that you can explore. Now what we're going to need is the Istio CLI. So I'm going to grab this Istio command line utility and move it to user local bin. So I just say move, and I move that binary to user local bin. And then the next thing I do is give it execution rights with chmod. And now I can say Istio CTL. And we can see the command line is now installed within our little container. And then what I'm going to do is I'm going to move this Istio folder that we have in our root here. I'm going to move it to a temp directory, just so that we can refer to it later. So Istio also has this pre-flight check command. We can say Istio CTL X pre-check, and this will go ahead and query our cluster and do a pre-flight check before we install Istio to make sure it's compatible with our Kubernetes cluster. So if we run that command, we can see it does a bunch of things. It double checks the Kubernetes API, whether it can talk to it. It checks whether it's compatible with this version of Kubernetes. It says Istio will be installed in the Istio system namespace. It does a bunch of Kubernetes setup checks, sidecar injector checks, and then gives us a message to say our pre-check has passed. Now before we install Istio, it's very important to understand that Istio has a concept of configuration profiles. So this is very well documented under the configuration profiles page in the documentation. They have 6 types of profiles that are deployable. There's default, there's demo, there's minimal, remote, empty, and preview, and these are pretty self-explanatory and well documented. And they also show you a little matrix here with all the components that are installed with each profile. They also recommend that the default profile is recommended for production deployment, so that is the profile I'm going to be taking a look at today. I've put a link in my document here to the documentation of the config profile, so be sure to check that out. We can see a list of profiles by running Istio profile list, and if we run that, we can see the available profiles, and then we can go ahead and install Istio by running istio-ctl install and setting a profile. So I set my profile to default. This will go ahead and install Istio in the Istio system namespace. So if I run that, we can see this will take a couple of seconds to be completed, and once it's done, we can see it spits out a couple of messages: Istio cores installed, Istio D, the ingress gateways, add-ons, and the installation is complete. I can go ahead and confirm this by running kubectl in the Istio system namespace. I can say get pods, and we we should see everything up and running. I can also run this Istio proxy status command to see the proxy status of the cluster. Now let's go over the basic architecture of Istio. So if we say kubectl in the Istio system namespace get pods, we can see the service called Istio-D, and this is the pod that makes up the control plane of the Istio service mesh, and we can see it in the diagram over here. Now Istio-D is responsible for injecting these sidecar proxies into our services that are part of the mesh. Those applications that opt in then become part of the service mesh. All these applications that then become meshed form what's called the data plane. And we can see this pilot component within Istio-D. Now the pilot component is what's responsible for traffic management and injecting and managing the lifecycle of these envoy sidecar proxies that we inject into our service pods. The Citadel component of Istio-D is basically the certificate authority which helps achieve mutual TLS between services that are part of the mesh. The gallery component in Istio-D is basically what translates Kubernetes YAML into a format that Istio understands, and this helps Istio to run outside of Kubernetes as well. So now that we have an Istio service mesh running in our cluster, it's very important to note that none of our services and applications are part of the mesh. Istio service mesh provides a capability to opt in for services to become part of the mesh. And there are two ways for services to opt in to become part of the service mesh. The first way is you can either just label a namespace. That means all pods that are running part of that namespace will become part of the mesh. So you can either mesh an entire namespace, or the second approach is you can use Istio-CTL to grab the deployment YAML and inject the envoy sidecar proxy using Istio-CTL. This is a more manual approach but allows you to opt in only for specific deployments. And this is useful if you want to engage in a staged approach where you install Istio and then you only apply it to certain microservices until this technology matures within your team. And then you can proceed to use the entire namespace. So to have all these pods in the default namespace join the service mesh, I can apply the Istio injection equals enabled label on a namespace. And once I apply this label to the namespace, Istio will inject the envoy sidecar proxy into any new pod that gets created. So I can say kubectl label, I can label the default namespace with Istio injection enabled. So if I go ahead and do that and we run kubectl get pods, we see nothing happens. This will only take effect for new pods that get created. So to have Istio inject the sidecar proxies to each pod, what I can do is I can say kubectl delete pods all, and that'll force Kubernetes to create new pods. And when it does that, Istio will inject that sidecar proxy into each one of these microservices. And if we do kubectl get pods, we can see that there are now two containers within each pod. So we have our application in each of the container as well as the sidecar proxy. And if we wait a couple of seconds, we do kubectl get pods, we can see all of our services are now meshed. So now our entire namespace is basically meshed using this label concept. If you want to manually mesh deployments, you'll need to use Istio-CTL. So let's use the manual injection method on our ingress controller. Now Kubernetes has a method of getting the YAML out of the cluster. So I can say kubectl in the nginx ingress namespace. I can say get deploy, and I can get the deployment of that nginx ingress controller, and I can output it as YAML. And when I do that, we can see kubectl spits out all the YAML for that deployment to the terminal. And what this allows us to do is pass that YAML to the Istio-CTL command line. So I can pipe that into Istio-CTL kube inject, and when I grab that and I pipe it to the Istio command line's kube inject function, I copy that and run that, we can see it also spits out YAML to the terminal. But it's important to note, if we take a look at the YAML it produces, we can see that it has our initial deployment here for our nginx ingress controller, but it also injects a sidecar proxy. So to inject a sidecar proxy into our deployment, we have to pass that YAML to kubectl apply. So to summarize that, we say kubectl get deployment, we output our original deployment as YAML, we use Istio-CTL kube inject to inject the sidecar proxy YAML into our original YAML, and then we take the output of that and apply that back to the cluster. So if I paste that, we can see our deployment is now configured. And after a couple of seconds, we can see we have our nginx ingress controller pods here, and both of them are now meshed. And because we've created new pods, I have to jump back to this terminal where I had this port forward command and just Control-C and port forward again. And that's as simple as that. Now all our microservices, including our ingress controllers, are all now part of the service mesh. Now to simulate some traffic to our application, instead of just refreshing the browser page, let's write a small script that runs in a loop that continuously makes web requests to our microservice architecture. So to do that, I'm going to open up a new PowerShell terminal and I'm going to run this small while loop. I'm going to say while true, and I'm going to make a request to servicemesh.demo/home, and then to simulate the call to the playlist API, I'm going to say curl, and I'm going to do the same thing to the playlist API, and then I'm going to sleep for 1 second. So this is going to run in a loop continuously every second and make a request to the browser page as well as the playlist API. I'm going to copy this guy and paste it to the terminal, and then I'm just going to leave this running in the background. Now the cool thing of having all our services part of a service mesh is the proxies that are running as sidecars in our application exposes rich telemetry about all the network traffic between these services, and we can visualize this telemetry in 2 ways. Istio comes pre-shipped with a Grafana add-on as well as a Kiali add-on. These are dashboards that we can go ahead and deploy, which will allow us to look into the network. So let's take a look at the add-ons. If I do ls on the temp folder that we used earlier, we can see we have the whole Istio directory there that we downloaded. And if we take a look at that, we can see inside is a samples directory. And if we take a look at the samples directory, we can see inside here is an add-ons directory. And if we take a look at the add-ons directory, we can see there's a Grafana YAML, Jaeger, Kiali, and Prometheus. So these are the add-ons for Istio that we can go ahead and install. So to get some telemetry out of the Envoy proxies, we can run kubectl apply, and we can apply this Prometheus YAML. This will go ahead and deploy Prometheus into the Istio system namespace, and will start scraping metrics out of each of those proxies running in our service mesh. And to get a dashboard, we can deploy the Grafana add-on. So we can say kubectl apply in the Istio system namespace. We can apply the Grafana YAML. And if I go ahead and do that, we can see it'll deploy a Grafana deployment to the Istio system namespace. And if I do kubectl get pods in the Istio system namespace, we can see we've deployed Grafana as well as Prometheus. So now that we have Grafana installed, we can access it with the Kubernetes port forward command. So we can say kubectl in the Istio system namespace port forward to the Grafana service on port 3000. So if I run that, I can head over to the browser on localhost port 3000, and this is the landing page. And the first dashboard we're going to want to look at is the Istio mesh dashboard. This one has a summary overview of all the namespaces and services that are meshed in the cluster. So you can see on the left here we have services, and then we have workloads, which are 2 separate dashboards. We can see our videos web, which takes the traffic for the browser page. We can see our videos API and playlist API. We can also see the number of requests per second, the latency percentiles, and the success rate. So this is very useful for setting up alerts and having an overview of the networking in your cluster. So the left dashboard is more around the Kubernetes services. So if we go into something like the playlist API, we can see like the number of requests per second, the service success rate, the duration, latency percentiles, and if we scroll down, we can see the service workload. So we can see things like duration by source, we can see the request size and the response sizes. And if we go back in the middle here, we got the workloads. This is the interesting one. So if I go into the playlist API, we can see again incoming request volumes, success rates, we can see the request durations, we can see TCP client traffic. This is probably the request to our database. And this is where it gets interesting. We can now track inbound workflows. So we can see all our traffic coming into the playlist API from the Nginx ingress controller over here. So we can see basically where the traffic is coming from. We can see the success rates. We can see incoming request duration by source, request size by source, and the response size by source. So this gives us a good overview of the inbound workflow. And if we go to the outbound services, we can see the outbound calls. So the playlist API we know makes internal calls to the videos API, and we can see the success rate over here. We can also see request duration and sizes, and we can also see outbound TCP connectivity. So we can see we're calling our playlist database over here. And if we go back to the landing page, we can also drill down into the videos API and see the same thing over there. So we can see success rates, request volumes, and durations. We can see inbound calls. So remember, the inbound traffic will be the playlist API. And we can also see that all requests have mutual TLS between them. So we can see secure traffic over here. We can see all inbound requests are coming from the playlist API, response sizes by source and request sizes, and we can see outbound calls. So now outbound calls, we will only see our database TCP connectivity to the videos DB. And then we can see the same thing for videos web, which is our web server that serves the landing page. And because we're doing a sleep and a loop, we can see we roughly have just under 1 request per second hitting the videos web. We can see the success rate, the request duration, and we can see the inbound workflows. Now, because all requests comes through the Nginx ingress controller, we can see that here. So the inbound workflow is all the Nginx ingress controller traffic, and we can see duration by source, request size by source, and the response sizes. And there is no outbound connectivity here. Now, this is what's called black box metrics, and it's the highest benefit of having a service mesh is that we get all of this telemetry for free without making any code changes. So we get all this network observability regardless of any programming language. All we have to do is add our service to the service mesh. Another similar dashboard that's really useful is the Kiali dashboard, and if you want to deploy that, that is in the add-ons directory as well. So if I do ls and I list out the samples add-ons folder, we see Grafana is here. We also have kiali.yaml, so we can simply deploy that by saying kubectl apply, and we can apply that YAML file. So if I do that, we can see that it'll deploy Kiali in the Istio system namespace, and the first time you run this, you'll get a CRD error. That is because Kiali will go ahead and generate some CRDs, so we give it a couple of seconds and we run the command again, and this time you'll see it will pass without any errors and the CRDs will be created. And if I do kubectl get pods in the Istio system namespace, we can see Kiali operator is now being created. And similar to Grafana, we can go ahead and port forward, so we can say kubectl in the Istio system namespace port forward to the Kiali service on port 20001. So if I go ahead and run that, that'll expose the Kiali endpoint on localhost 20001. Now Kiali is very similar to Grafana as it shows us workloads as well as services with similar metrics than we saw before. So if we click on workloads, we can see all our workloads that are part of the mesh over here, and it also allows us to drill in. So I can go into the playlist API and I can kind of go through these metrics at the top here. So we can click on traffic, we can see inbound traffic is coming from the Nginx ingress controller, outbound traffic is going to the videos API and the playlist database. We can look at the inbound metrics, so very similar to what we saw in Grafana with the inbound traffic. We can also see outbound metrics, so also very similar to what we saw in Grafana. But the cool feature that Kiali has is it has this graph section which shows you like a graph of the traffic, so you can actually visualize how traffic is flowing in your cluster. So we can see all the traffic is coming from the Nginx ingress controller, it's passing through, it's hitting videos web, so that's the one loading in the browser. We can also see subsequent requests from the browser coming through the Nginx ingress controller hitting the playlist API. We can see the playlist API making a call here to the playlist database. We can also see it making calls to the videos API, which the videos API is then calling its database. So we can get a nice graph of the network over here as well. The other thing that Kiali has that Grafana doesn't have is we can also manage Istio configuration. So as you start building out the Istio mesh and start taking advantage of things like virtual services, you can come into here and you can filter by namespace and then look at different Istio types. So you can start filtering on things like sidecar, service entity, gateways, destination rules, and virtual services. So in here, we'll be able to see things like traffic splits, retry rules, timeout rules, and Canary deployment rules. Now, to define these types of rules, we have to interact with the Istio CTL and create some of these Istio objects with the main Istio object called virtual services. Now let's say the team responsible for the videos API commits and deploys some buggy code to the Kubernetes cluster. There may be a lot of teams doing multiple deployments throughout the day. Now let's see how we can use these observability tools to locate and track and solve this problem. So I've written some buggy code on the videos API that I can turn on using an environment variable. So to simulate that, I'm going to say kubectl edit deploy. I'm going to edit the videos API and I'm going to go down to the environment variable section and I'm going to turn this environment variable called flaky to true, and I'm going to go ahead and save that. This will simulate someone checking in some buggy code and deploying it to our cluster. And if we say kubectl get pods, we can see that change has been deployed. And now we most likely have alerts firing to our development teams, and we can see here that there's a large failure happening in our cluster. We can see the videos API as well as the playlist APIs being impacted. Now before we make assumptions about where the failures are, let's use the Istio dashboards to figure out and find and the problem. So the most logical place to look at is the playlist API, as we know that that's where all the traffic is coming in. So if we go to the playlist API workload, we can see that the incoming success rate has dropped. We can also see the request duration has spiked up by quite a lot. And if we take a look at the inbound workflows, we can see that our Nginx ingress controller request per second has dropped a little bit as well. So we can see that the Nginx ingress controller is impacted by this change. We can also see that the Nginx ingress controller is receiving errors as it started right over here. And also we can see that there's been a huge spike in the request duration. So our Nginx ingress controller is definitely being impacted as the requests are taking much longer to come back. We can also see that the outbound calls to the videos API are failing as well. And there's a huge spike in latency to the outbound requests to the videos API. And what's interesting here about the outbound services is if we take a look at the request response codes, we can see that we're getting 503s from the videos API. And if we search for the 503 error code, we can see that this means that service unavailable. So we are getting a service unavailable error for network traffic going to the videos API. And for interest sakes, we can jump into the videos API as well. And we can see the incoming success rate has dropped dramatically. And if we look at the inbound workflows and we look at the response codes, we can see 503s are being synced to the playlist API. So there's an obvious issue with the videos API here. And if I go and check the logs to confirm, I can run kubectl logs on the videos API and I can just get the last 50 lines. And we can see we have a lot of exceptions happening. And we can see here the server is panicking with a flaky error. So we can see how useful these observability dashboards are to locate network problems. Now, while developers are working on a fix, which in reality can take a bit of time, and since the errors seem to be intermittent because we do have 200 and 503s happening, a virtual service may help us implement some form of auto retry logic, which can help us mitigate the error until a fix is deployed. Now, a virtual service is an Istio configuration that allows us to affect traffic routing. We use a virtual service to define what we want Istio to do with the traffic. Things like automated retries, Canary deployments, timeout settings, traffic splits, and more. So to begin with virtual services, if we take a look at my Kubernetes service mesh Istio folder, in here I have a retries folder and I have a videos API.yaml file, and this is what its virtual service looks like. So it's called kind virtual service. I give it a name and I tell it what host name to target. So in this case, I want all requests to the videos API and I want to implement auto retry on that traffic. So I specify host, I specify videos API, since that is the service name that's been configured in the playlist API to send requests to. I then say HTTP and I define a route destination, and the destination host is videos API. And then I also say I want to implement retries, and you can pass in a number of how many attempts you want to be retried, and also the retry timeout for every retry that occurs. But it's very important to understand the effects of auto retry. Too much retry adds extra requests onto the network, which can strain the network. So it's important to dial in this value so that you do just enough retries to make the error go away, but not too much retries to add too many strain on the network. So to deploy that virtual service, I'm just going to say kubectl apply in the Istio retries folder, and I'm going to apply that virtual service, and Istio will grab that and immediately start auto retry on that traffic. We should see that the requests from the playlist API to the videos API should start getting a higher success rate, and we can see that number is going up. And we can see now that the playlist API has fully recovered. So all requests to the playlist API are successful, which means if we go to our video catalog and we hit this page, we can see that there's no longer any errors. If we go into the playlist API, we can see that the 503 errors have now stopped, and now the Nginx is receiving 200 status codes. So that's how virtual service auto retry functionality can help us mitigate those errors. Now let's say a fix has come in, so I can go and say kubectl edit the videos API. I can go back to flaky true. I can set this to false, and let's say a fix has now come in, and then I can go ahead and safely remove that virtual service as it's no longer needed. Now let's say we want to implement a traffic split. Maybe we want to send 5% or 10% of traffic to a new web API or a new web interface. This might be useful for API testing. Now for traffic splits, I have a separate virtual service, which is in the Kubernetes, Service Mesh, Istio, Traffic Splits folder. Now let's say a development team has created a V2 of our videos web, and they want to send 50% of traffic to the new V2. So what I've done is I've created a new deployment with V2. We can see we're running videos web V2 and a new service. So I'm going to go ahead and say kubectl apply, and I'm going to deploy V2 of our videos web. And this videos web V2 has a new header that's in development that maybe the videos web team want to test. And I can do kubectl get pods, and we can see we now have videos web V2 running side by side with videos web V1. And if we take a look in the traffic splits folder, I have a videos web.yaml with a virtual service showing you how to split traffic for the videos web. Since all traffic is coming in over servicemesh.demo as a host, we want to create that as our host, and we want to route to a destination videos web V2 and videos web V1. And here we can specify a weight, so we can say 50% of traffic go to the one and 50% of traffic goes to the other. Now this is probably more useful for API type of testing, because usually we don't want customers to be flipping between user interfaces. I can go ahead and apply that virtual service saying kubectl apply in the traffic splits folder, and I can apply that virtual service. And if I go back to my servicemesh.demo/home and I refresh it, we can see that I'm hitting the new V2 service over here. And if I refresh it again, we can see I'm back on V1. I refresh it again, I'm on V2. So we're bouncing 50-50 between videos web V1 and V2. Useful for API testing, maybe not so useful for UI testing. Now traffic splits has its uses, but in a microservice architecture, many teams utilize feature toggles to turn certain features on and off. We may not want traffic to bounce 50-50 between services. Now usually what development teams like to do is set a cookie in the header for a small percentage of customers, and that cookie value allows us to send only a portion of that traffic to our new V2 videos web. By setting specific cookie values, we can turn certain features on and off and send a portion of customers to different areas of our system. This is called Canary Deployments. Now for Canary deployments, I can go to the Kubernetes, Service Mesh, Istio folder, and I have a Canary folder with a virtual service. And this virtual service name is called Videos Web Canary. And similar to our traffic split, we want to target all traffic with where the host is servicemesh.demo. And then in here, under the HTTP section, I have two match patterns. The first match pattern looks for URLs where the prefix is /, so basically all traffic coming into our videos web. And I want to specifically match a cookie with this regex statement. So I'm looking for version equals v2 in the cookie header, and then I want to route all of that traffic that matches this pattern to videos web v2. And to send traffic to v1, we want to add another match pattern where we only simply say that we want the URL prefix as / without the header of the cookie regex, and that traffic we're going to send to destination videos web, which is v1. Now before I apply that, I'm just going to go ahead and delete the virtual service we created for traffic splits, as that may interfere. And then I can go ahead and deploy this virtual service saying kubectl apply -f in the Istio Canary folder, and I want to apply the videos web YAML there. That'll go ahead and deploy our virtual service. So to try out our Canary deployment, I can go ahead and access our servicemesh.demo/home/ in the browser, and if I hit that page, we can see we're on v1. So what I want to do is press F12 to go to the developer tools, head over to application, and we can see we have cookies here. We can expand this and we can add a cookie version equals v2. And once I've set that cookie and I open this page in a new browser window, we can see now we're stuck on the v2 of our web interface. And we can see now that all our traffic is going to this Canary deployment of v2. So that's a ton of information on the basics of Istio that'll hopefully help you with your Istio journey. Now be sure to check out the source code link down below and try to take it for a spin. And let me know in the comments down below about your Service Mesh experience. And remember to like and subscribe and hit the bell. And also check out the community page in the link down below. And if you want to support the channel even further, be sure to hit the join button down below and become a member. And as always, thanks for watching, and until next time, peace.